Yeah, welcome to VLSI Simplified YouTube channel. As a part of this Verilog 30 days Verilog series, we are in day 15. Today I will explain you the Verilog code, RTL code for gray counter, okay, binary to gray counter. That is in EDA playground and AMD Vivado and as well as Quarter Prime and ModelSim. So first we'll see in the EDA playground what is this. So we'll see the RTL code as well as a test bench. Okay. So if you see the RTL code, this is our RTL code. So here, module, what is my module name? Gray underscore counter. I need to declare the inputs and outputs. So input clock, input reset, output range 3 down to 0, gray counter. So I'm declaring with a vector that is 3 down to 0. So this is 4 bit. Okay. So 3 down to 0, gray count, gray underscore counter. So I need to declare one intermediate variable that is 4 bit, range 3 down to 0, binary underscore counter. Always at the rate passage of clock begin if reset equal to 1, begin gray count equal to 4 tick binary 0 and binary count equal to 4 tick binary 0. Okay, and else begin. So that means you are initializing when reset equal to 1, you are initializing the content of gray counter and binary counter. Else begin binary counter. So binary counter equal to binary count plus 1. Okay, and binary counter equal to binary count plus 1. And gray counter equal to what? This is the conversion from where to where, binary to gray. Okay. So like first you incremented the binary count. After that, whatever the binary count is there, you are converting from binary count to gray count. Okay. So that is gray count equal to. So this is the conversion. First, you are getting B3, and after that B3 equal to actually G3. Okay, B3 G3 equal to B3 and G2 equal to what? So successive XOR operation. So binary count 3 XOR operation with binary count 2. Okay. And next G1 equal to the successive XOR operation, binary count 2 XOR operation with binary count 1. And next this is G naught. G naught equal to binary count 1 XOR operation with binary count 0. Okay. And so this end. So actually in the F you have begin. Okay. So this begin and end, and after that this begin and end. Okay. So if there are multiple statements, we need to write between the begin and end module. Okay. So this is the basic gray counter. Okay. First you need to make for a binary counter. After that you need to convert whatever the binary into gray. Okay. This is the process to convert from binary to gray. Okay. So this is our RTL code. So we need to write the code within the procedural block. So this is actually behavioral modeling style. So that's why I'm declaring gray count with what? Reg data type. Okay. So this is about the RTL code. And coming to the test bench, if you see the test bench. So test bench have total 5 steps will be there. Module, my module name is TB gray counter. So I need to declare like as per port rule connections. So test bench doesn't have the inputs and output; it have the variables. Okay. So I'm declaring range clock reset, wire 3 down to 0 gray count, and next I need to instantiate the design. Okay. So gray count, that is DUT. Okay. This is my design name. Okay. What is my design name here? That is gray counter. Design name is gray counter. Instance name is DUT, and this is connection by name. So connection by name is what? So you'll get like this dot clock in the bracket clock dot reset dot gray counter count. Okay. So whatever the variables outside the bracket are design inputs and outputs. The variables inside the bracket are test bench variables. Okay. And after that, you need to generate the clock with 10 nanoseconds. So for generating the clock with 10 nanoseconds, we need to write initial begin. I'm applying initializing the clock equal to 1 tick binary 0. Okay. And I'm using forever hash 5 clock equal to not of clock. That means So it should be off for 5 nanoseconds and it should be on for 5 nanoseconds. Okay, total time period is 10 nanoseconds and the frequency is 100 megahertz. Okay, so this is about the clock generation. And next, you need to reset your sequence. Okay, reset the reg variables. For this, we need to use initial begin. So as in the code, if you take this is synchronous act to high reset. So when reset equal to 1, then we are initializing the gray count and binary count to uh, the zeros, no initial values. Okay. So here also first you need to initialize the the count values. Okay. For this I am applying reset equal to 1 tick binary 1. After 10 time minutes, I'm deasserting the reset. Here I'm asserting the reset. After that, I'm deasserting the reset after 10 time minutes. Okay. And end. So if there are multiple statements are there, you need to write between the initial begin and end. Okay. And next, uh, so this is for these are the two instructions you need to execute uh, for executing in the EDA playground. Okay. Dollar dump file my design name dot VCD. So what is my design name? Gray underscore counter dot VCD. Dollar dump vars 0 comma TB underscore gray underscore counter. Okay. And next, I need to use dollar monitor. This is a system task. So if there any change in the variables, okay. So if there any change in these variables, it may be time. I'm representing with format specifier percentage T and reset percentage B in terms of binary, gray count in terms of percentage B, comma dollar time reset gray underscore counter. Okay. So, so I need to check for 20 time minutes, that is hash 200, sorry, 200 time minutes, 200 nanoseconds. Okay. So I need to check for 200 nanoseconds. Dollar finish. Okay. Dollar finish is to terminate the simulation end module. Okay. So this is actually like test bench. We need to write the test bench. Okay. So this one I need to execute in EDA playground. How to execute? First, open the EDA playground. So one second. So open the EDA playground and log in with your mail ID. Okay. So you need to register with your mail ID. Okay. Need to register with your mail ID. So here, right side we need to write the design and left side we need to write the test bench. So this is my design. Right click, next select all, copy, and here you need to paste. And next test bench, right click, next select all, copy, and here test bench we need to paste. So go to tools and simulators. Select the tools and simulators are already Rivera and select this open EP waveform after run and save. Okay, and run this code. So I will get the waveform. See here. So that means initially this is XX only. This is actually binary count and this is gray count. Okay. For each and every binary count, you will get the gray count. Okay. So like so binary count is what? So during this passage of clock, always at the rate passage of clock, that is synchronous reset we have seen, no? So that is 0, 1 and 1, 0, 1, 1 for mm, so if you see 1, 1 and next 1, double 0. So if you see the gray count, so 0, 1 and for 1, 0 you are getting 1, 1. Okay. For 1, 1 you are getting 1, 0. Okay. This is actually gray code sequence. Okay. So for 0 it is same only. For 1 it is same only 0, 1. For 1, 0. For 1, 0 we are getting 1, 1. Okay. And for 1, 1 we are getting 1, 0. Okay. So the above is a binary counter. Okay. Next 1, 0, 0, 1, 0, 0, double 1, 0, gray code sequence. Okay. 1, 0, 1, triple 1. 110, we are getting 101. Okay, triple one 100. Okay, triple one 100. Okay, one triple zero double one double zero. Okay, 10001 double 101. Like this we can get. We can see in the log file also. So this is our gray code counter. Okay, gray count. So 0000. This is actually when you are applying the reset. So all the gray count and binary count becomes 0. Okay. And after that, when you are deassetting the reset, so gray count equal to all zeros, that is four zeros, and again 0001 and 0011, 0010. Okay. And this is actually 0110. So you can observe the gray count sequence. Okay. So this is about the gray code I'm executed in EDA playground. And next, I want to execute in Vivado. Okay. For this, go to File, Project, New Project. Next. Okay. I want to select the path where I want to store my project. Okay. So go to Training and Development. And so we are in VLSI Design Material and 30 days. We are in 15th, day 15, no? Okay. Select. So I'm giving the project name as what? Gray underscore counter. Gray underscore counter. Okay. Next and next. So give the file name. So give the file name. Let it be same as module name only. So what is my file name? Gray count, gray counter, copy, and here you paste. Choose the location. That is a gray counter. Select. Okay. Next. This is optional only. Next, next, and finish. Yeah. Module name is also same. This is my gray counter. Go to this, select all, copy, and here you paste, save, and go to simulation, add the simulation sources, create the simulation sources. Here we need to give the test bench module name. What is my test bench module name? TB underscore gray underscore counter. Okay. So copy this, and here you paste, choose the location, gray counter, select, okay, finish. Okay, yes. Here, yeah, this is my gray counter, and go to text bench, select all, copy, and here we need to paste, save. Now my this gray counter is design is instantiated in the test bench. Okay, so my design name is gray counter. Why? Because in the test bench we already given no. This is actually instantiating my DUT on that under the test bench. Okay, so that is DUT gray underscore counter, gray underscore counter. So that's why it is instantiated in my test bench. Okay, suppose if you want to see the RTL netlist, go to RTL analysis and open elaborated design. Yeah, like this in terms of D flip-flop and XOR gate and one more adder. Okay, so adder like we are using counter, no? So like this, the tool is converting our code into gate level netlist. Okay, So like four D flip-flops, and this is actually like binary to gray counter. Okay, so we are getting. I told you the conversion, no? So like G3 equal to B3 and G2 equal to successive XOR operation. Okay, B3 XOR B2 like that. We will get now. So that only, and yeah, this is our gate level netlist. And go to, so for the simulation, go to simulation, run behavioral simulation. So you can see in the TCL console also. So this is actually my gray counter I'm getting. Okay, gray counter. So you know the gray code sequence. Okay. So so like 0, 0, 0, 0, 0. So actually when reset is applied, this is always 0 only. Here I'm desetting the reset. So 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. Like this I am getting. Okay. And next, go to the simulation, and here fit to page. If you want to see in the binary, right click, radix, binary. Okay. So I will get during this passage of clock, I am getting the gray code sequence. Okay. So 0, 0, 0, 1. Okay. So here reset is becomes 0 means so when reset equal to 0, it will go into the functional mode. Okay. I need to see in the passage of clock only. So passage of clock, if you see, so that means we are getting the gray code sequence 0, 0, 0, 0, 0, 0, 0, 1. After that, so gray code means the value, each and every bit is differ by 1 bit position. Okay, unit distance code. Okay, so unit distance code. That's why we call as gray code, and mostly we are using in low power applications for this gray code, and parallelly for 2-bit gray code we are using in the K maps. Okay, in the K maps for minimizing the Boolean expression into minimum number of literals. Okay, there we are using the gray code. Okay, 4-bit 4 variable K map or 3 variable K map. So we are using the gray code. Okay, this is the so I showed the circuit as well as the simulation in the Vivado. Okay, and coming to the quarter spread. So this is my quarter spread. Go to new project wizard. So next, so I need to choose the location where I need to store my project. So here if you see, let's say material 30 days and 15th. Uh, I need to choose this sim folder. Okay. And what is my project name? Give the same module name only. Okay. So record next, empty project next. So here in this folder, I created three files. One is RTL, whatever the RTL related code is there, I stored in RTL, and TB. TB means TB related, test bench related file. Okay. So here go to upload the file, RTL file. Here you see VLSI material 30 days. Day 15, RTL, gray code counter, open. Next, select any FPGA family. Next, next, and finish. Now the RTL file is uploaded in the entity instance. Go to analysis and synthesis, start. Yeah, I got zero errors. Go to analysis and synthesis, netlist viewer, RTL viewer. So go to RTL viewer, open. So I got this RTL file. Okay. So in terms of D flip-flops, muxes, and XOR, so this is a conversion from binary to gray and plus like that I'm getting. Okay. Next, coming to the model sim, go to file, new project. Okay. So I want to close this. So give the module name only. So ModelSim is for simulation part. So right click, copy, and go to here. Project name is gray counter. So we are in day 15 no. So just select the uh, project location. Okay, where you want to store the project. Okay, and upload the RTL file as well as TP file. So if you see in day 15, RTL file, gray counter, open, okay, upload the TB file also. So this is my TB file, gray counter, open, okay, close, okay. Next, just right click, compile selected, and go to library, go to work, and right click, simulate, simulate the test bench, okay. After this, you simulated, no? So gray counter TB, add wave, DUT, add wave. Okay. So here, so this is gray counter TB. So you need to group the TB files. Right click, group. This is TB file. Okay. And next, right click, group. One second. DUT files. Right click, group, DUT files. Okay. And next, go to run all. Okay. And, you can see in the, so just zoom full. One second. Here, somewhere, I'm not getting the output. One second. Just I will update this. So uh, quit -sim here project. I want to add the project. I want to close this. Remove from project. Add new file. So what is my file name? That is mm, training and development, and day 15, RTL. One second. Mm, so go to file, mm, project. Okay. Give the file name only. gray underscore counter. Okay, location is same. Okay, so add this files, gray counter. Okay, add these files, test bench files, gray counter, open. Okay, close, right click, compile selected. Yeah, so go to library, work, gray counter underscore TB, simulate, and go to DUT gray counter underscore TB, add wave, DUT, add wave, and here you need to group the TB files, right click, group TB, okay, DUT, right click, group DUT, okay. Now go to run all, no, okay. So you got the gray code sequence. This is a gray code sequence in terms of decimal you got, and in terms of waveforms also you can see. So just you can see the waveform, zoom full. Here you got the gray code sequence. So here if you see the TB file, so gray code, so this is a gray code counter. So 000, after that 001 and 011, 0010. Again, next, during this passage of clock 0110, 0111, and next 0101, 0100, and 1100. Okay, like this we are getting. Okay, so gray code counter we are getting. Okay, gray code counter. So this is actually binary counter. So binary counter. This is my DUT output. Okay, DUT design and test. DUT output I am getting binary counter and related to this gray code counter. Okay, and in the transcript window also you can see. Okay, transcript window. This is a counter, whatever the counter values are. Okay, so like this we can see the waveform. Okay. So hope you understood. This is actually gray counter. So we seen in the EDA playground and AMD Vivado and Quartus Prime and as well as ModelSim. Okay. So QuastaSim also same process only as well same as ModelSim. Same process in QuastaSim also we can execute. Okay. Okay. Thank you.